So we continue solving, but this time it's not adding, it's subtracting. This time it's multiplying and dividing. And so if you remember when we talked about adding and subtracting, we talked about inverse operations. And multiplying and dividing are inverse operations of each other. See, multiplying, you're putting things, you're putting groups together. So you have like 2 groups of 3. So you're putting them together to make 6 total. But in dividing, you have something and you're dividing it into groups. And you're asking how many are in a group. So you're undoing each other. Multiplying and dividing are undoing each other. So when you have an equation, for instance, if you had 2x equals 3. And I purposely pick numbers that aren't easy because otherwise you just think in your head and solve it in your head. So if you have 2x equals 3, here's the first thing you need to understand. This 2x is really 2 times x. Some people think the 2x, like the 2 is like glued to the x and you can't separate it. That is not the case. This is just saying we have 2 x's. We have 2 groups of x. And so to solve it, it's being multiplied right now. It's 2 times x. So to solve it, we do the inverse operation, which is divide. So it's already the groups are put together. Now we're going to take the groups apart. So I'm going to go ahead and divide. But once again, I've got this balance scale. So whatever I do to one side, I've got to do to the other to keep it balanced. And we have this right here. Whenever you have a number over itself, 2 divided by 2, it makes a 1. So really I just have 1x, or you can look at it as just x, because 1x is just saying that you have 1x, which is what x is just 1x. So x equals, and then 3 halves, well, I can't take 3 divided by 2 and get an even or a whole number. I would get a decimal, and that's fine if you write the decimal, but I am perfectly happy. In fact, I would rather you just leave it as 3 over 2, and that's your answer. Okay, the same thing goes for division. Let's say I started out with x over 2 equals 3. So again, a fraction is really division. So that is really x divided by 2. It's been split into 2 groups. And now I want to put it back. So I undo the division. And that means I'm going to multiply by 2. And here's how we show multiply. You do not use an x in algebra because we don't want to confuse it with the x of the variable. And so what we'll do is we'll put a little dot on either side. And I'm going to put it on the side. I'm not going to put it on the bottom. If I put it on the bottom, I'm just dividing by 2 again. Anything on the bottom is division. So what I'm doing is I'm putting it on the side so that I'm saying, hey, I'm multiplying this whole thing by 2. And I'm multiplying this whole thing by 2. Now this is technically 2 over 1, so really the 2 is on the top. And so once again I get my 1. These guys cancel out to be 1, right? So they cancel out and I just get x equals 3 times 2 is 6. Okay, so inverse operations, if it starts multiplying then you divide, if it starts by dividing then you multiply. Now sometimes you have something that is both. So let's say I have 14 equals 7/8 m. So technically when I look at the 7/8, the 8 is on the bottom, which means I'm dividing by 8. So undo that, I would multiply by 8. The 7 is on top, so technically I'm taking 7 times m because m is technically over 1, right? I can write m over 1. And so technically it's 7 times m. So I could do this in 2 steps. I personally would get rid of the 8 first, so I would multiply by 8. Right? Then the 8s are 1. And so now I just have 7 times m equals 14 times 8. And then I want to divide by the 7, so I want to get rid of the 7, so I'm going to divide by 7 on both sides. And so those cancel to 1. And so now I just have an m there, and then I have all this math on the other side. Now, one thing we talked about in class was if you look at this, I start out with 7/8, and then I end up with 8 over 7, the reciprocal. And so if you want, when you have a fraction, you can either do what I did and do both things separately, or you can look and say, I'm going to multiply by the reciprocal. The 7s and 8s become 1. And then I have 4 over 1. Oh, that's supposed to be a 14. But you get the idea. Now, when you have this 14, times 8/7. So I'm going to go back up to the top here. 7 goes into 7 once, 7 goes into 14 twice, so I can do that math. And then on the top now I have 8 times 2, that's 16. And on the bottom I have 1, but 16 over 1 is just 16, so I'm just going to write 16. But if you write 16 over 1, that's perfectly fine. You can do that. Okay, so we had the three things. If you're multiplying, then to get rid of it, you would divide. The second one is if you're dividing, to get rid of it, you'd multiply. And the third one is if you have a fraction. When you have that fraction times the variable, it's really just multiplying and dividing. So you could do both, or you could do it all in one step and do multiply by the reciprocal.